consider the cantilever beam with three types of load. Three types of load is nothing but point load, UDL load and UVL load. So UVL load is nothing but uniformly varying load, and UDL is nothing but, you already know what is that UDL load, and point load. So now calculate shear force and bending moment values. So shear force value at A is positive 10 kilonewtons and at D is 10 kilonewtons, because of we are considering section just left of the D. So at just left of the D, the intensity of load at right portion of the D is 10 kilonewtons and the intensity of UDL is negligible, because of we are considering just left of the D. So intensity of load is negligible. So total intensity at right portion of the section D is 10 kilonewtons. So at right of the section, the downward forces are positive. So both signs are positive. So then shear force at C, the intensity of load at right of the section at C is 10 kilonewtons and 2 kilonewtons of UDL. 10 kilonewtons of point load is 10 kilonewtons plus the UDL intensity is in terms of kilonewtons, we have in terms of kilonewton per meter, but units of shear force is kilonewton. So convert this kilonewton per meter into kilonewton by multiplying with distance of intensity of loading. So that is nothing but 2 kilonewtons into the acting distance is nothing but 2 meters. So total shear force at point C is nothing but 10 plus 4, 14, positive 14 kilonewton. So shear force at B is at B, just consider the section just left of the B. So intensity of loading right of the section is nothing but 10 kilonewtons and 2 kilonewtons, and the intensity of this UVL is negligible, because of this intensity is negligible value. So shear force value at left of the B, right of the B is nothing but 14 kilonewtons, because of 10 kilonewtons plus 2 into intensity of load is 2 and acted distance is 2 meters. So this is the shear force value at B, same as shear force value at C. So next shear force value at A. At A we have total three types of load, nothing but point load and UDL load and UVL load. So intensity of this loading is, due to point load is 10 kilonewtons plus due to UDL load is 2 into 2 plus UVL. You convert the UVL, uniformly varying load, into point load by multiplying with by area of triangle is nothing but half into base is nothing but acted distance is 2 meters and height is nothing but intensity of loading. This is the conversion of UDL load into point load. So here 2 cancel and intensity 3 plus 4 7 plus 10 17 kilonewton. These are the shear force values at different points of the beam. Next bending moment values. So bending moment at E equal to 0, because of already you know the shear bending moment value at the end of the cantilever beam is 0. So next bending moment at D. So bending moment at D, the considered section is just left of the section, the intensity of this UDL is negligible. Just consider this point load and their perpendicular distance. So point load is 10 kilonewtons and perpendicular distance is 1 meters. So due to the point load, the moment will be like clockwise movement, so take positive. So total bending moment is nothing but 10 into 1, so positive 10 kilonewton meter. This is the units of bending moment. Next bending moment at C. Bending moment at C is nothing but the total loads into their perpendicular distance. So total loads are plus positive 10 kilonewtons into perpendicular distance is nothing but 1 plus 3. from here to here is 3 meters. 3 meters plus, so due to this UDL load, the movement will be like clockwise, so positive. So just load into distance, this is the point load into perpendicular distance is this point load will be acted at the center of the acting load, center of the UDL load. Also center of the UDL load is nothing but here from C to here is 1 meter. So from here to here is nothing but 1 meter. So this is the 1 meter. So distance is from center of the load to point C is 1 meter. So total movement at C is nothing but 10 into 3 is 30, 30 plus 4, 30 plus 4 is 34 kilonewton meter. This is the bending moment at C. Next, bending moment at E. Bending moment at B is force into perpendicular distance. Thus the force is nothing but, first consider the force 10 kilonewtons and 2 kilonewtons. First of all consider 10 kilonewtons. So positive 10 kilonewtons into the perpendicular distance is, so perpendicular distance is so okay, so perpendicular distance is 10 into 2 plus 2 plus 1, 1 plus 2 plus 1, so total is 4 meters plus 2 into 2, this is the point load, and their perpendicular distance is here we are calculated 1 meter plus 1 meter. So this is the 1 meter from here to here. Next the 1 meter from C to B, so total distance is 1 plus 1, 2 meters. So into 2, this is the total bending moment value is nothing but 10 into 4, 40, 40 plus 4 2 is 8, 48 kilonewton meter. This is the bending moment at B. Next, bending moment at A. So bending moment at A is nothing but force into their perpendicular distance. First of all consider 10 kilonewtons into the perpendicular distance is nothing but from here to here is 1 plus 2 plus 1 plus 2. So total distance is 6 meters. Plus due to this UDL load, convert the first of all UDL load into point load. So UDL load into point load converted by multiplying the distance into distance. Next, the distance is nothing but from center of the point load to center of the UDL load to considered point. So from center of the UDL load to considered point is 1 meter plus 1 meter plus 2 meters. Total is 4 meters. Plus due to this UVL load, first of all you convert the UVL load into point load by triangular area. We are already calculated this load is 3 kilonewtons. So calculate again, half into base is nothing but 2 meters and height is nothing but intensity of load. So this is the point load, and distance is acted at the central distance. From here the central distance is from bottom of the triangle to mid third is nothing but 1/3. It is acted from 1/3 distance from base of the triangle. This is the triangle portion. This is the triangle portion and this is the base. So from here to here the acted distance is 1/3. So distance is 1/3 of 2 meters. This is the intensity of loading, intensity of bending moment due to the all loads at point A. So total bending moment is nothing but 10 into 60 plus 4 4 is 16 plus 2 2 to cancel, 3 3 cancel, total is remaining is plus 2. So 18 plus 60, 78 kilonewton meter. This is the bending moment value at A. So then draw shear force and bending moment values. So draw shear force and bending moment values. So initially to draw baseline. So this is the baseline. At shear force value at E is, this is the point E. At E the shear force is 10 kilonewtons. Here 10 kilonewtons. At D also 10 kilonewtons. At C 14 kilonewtons. At C 14 kilonewtons. at B, what is the shear force? 14 kilonewtons. At A, the shear force value is 17. So join these points as per the load application of loads. So from here draw straight line. So between these loads, nothing but this point E and point D, there is a no UDL load. So variation of shear force diagram will be straight line. So then from D to C, the variation of shear force is linear because of there is UDL load is acted. So then from here to here, so nothing but C to B, there is a no load, so that join by straight line. Then from here to here, so nothing but B to A, the intensity of load is UVL. So these points are joined by 2-degree parabola. So variation of shear force is 2-degree parabola when the UDL load is, the UVL is acted. These are the shear force. This is the shear force diagram, SFD. SFD. Here the variation is straight line variation, and here linear variation, here straight line variation, and here 2-degree parabola. These are the variations of various types of load, variation of bending moment for the various types of load. So next consider the bending moment diagram. So initially draw baseline. So bending moment at A is 0. Next bending moment at D is nothing but here. The bending moment at D is 10 kilonewtons. This is the 10 kilonewtons meter. Next bending moment at C. Bending moment at C is 34 kilonewton meter. At bending moment at C is here 34. Sorry, bending moment at D is here, and bending moment at C is nothing but here. Bending moment at C is 34 kilonewton meter. Here 34 kilonewton meter. And bending moment at B is 48 kilonewton meter. Here 48 kilonewton meter. Next bending moment at A. Bending moment at A is here is nothing but 78 kilonewton meter. Here 78 kilonewton meter. So join these points as per the application of load. So here bending moment at B is 0 and bending moment at D is 10 kilometers. Between these points, the bending moment will be vary as linearly. This is the variation of bending moment between these 2 points, and due to this UDL load between C and D, the variation of bending moment diagram will be parabola. So second degree parabola. Second degree parabola. So here the second degree parabola, it will be look like this. So next between the C and D there is a no load. So due to that, the variation of bending moment diagram will be linear. So here the bending moment diagram variation is linear. So then the between this A and B, the application of load is UVL. So UVL will be due to UVL load, the bending moment diagram will be vary as a third degree parabola, cubic parabola. So this is the cubic parabola. This is the third degree parabola. This is the bending moment diagram. For any type of load, the straight line variation will not occur in the bending moment diagram. Just the variation of bending moment diagram will be start with the linear variation. So here variation is linear. Here parabola. Here linear, and here third degree parabola. This is the bending moment and shear force diagram for the 3 types of load. So calculate the shear force and bending moment diagrams based upon draw the shear force and bending moment diagram like this. Thanks for watching. Please subscribe and share my channel. I hope this is helpful for your academic year and any type of competition. So thanks.